Hello, everyone, and welcome to day 3 of Advent of Cyber 2023 by Tryhackme. My name is Michael, and this is my channel, Cyber B Hub, where I talk about and learn cybersecurity and IT-related topics. So in today's video, we are doing brute forcing with Hydra. It says Hydra is coming to town, day 3. To give you a little bit of background about brute forcing, and it's a method used by offensive cybersecurity team and malicious actors or hackers to discover passwords, pins, encryption keys, etc. Brute forcing involves trying all possible combinations of passwords until a correct one is found. I would say my best analogy for this is, let's say you're in front of you is a locked door, and you're given a set of 100 keys, and one of those keys is the correct one, but you don't know which keys is the right one, so you have to try each key until you eventually unlock the door. So there's basically brute forcing is kind of in the same concept. However, this is only effective. Brute forcing is only effective if you have a complete understanding of your target. So let's say if you are an offensive security person, you have to ask yourself, have you done enough reconnaissance of the target? Have you enumerated the target's systems correctly? Do you know how strong their security measures and implementations are, or their account policies? And also, do you know who's the system administrator is? What do they like? What they don't like? When is the shift change gonna be? And the list goes on from there. But brute forcing is one method out of many, so it does not work all the time, but when it does, it's a very effective tool. So for our learning objectives for today, so after we complete the task, we will learn about password complexity and how to calculate the number of possible combinations, how the number of combination affect the effectiveness of brute forcing. We're also going to use Crunch as our password generator. And lastly, we'll learn about Hydra, which is a tool for brute forcing. So coming down here in section, so let's talk about password complexity and how it affects the likelihood of success of brute forcing. So let's say here, let's look at the pin codes, right? So pin codes are usually consist of numbers from 0 to 9. And let's say for this example, we have 4 pin codes, like this ATM right here. And so how do we calculate how many combinations a 4-digit pin might have? So if you think about it, that's anything from 000, 4 zeros, to 4 nines, like 9999. So that's about 10,000 possible numbered combinations. So that's very few, and someone has the tool to brute force, it can be easily brute forced within a matter of seconds or less than a minute. And depending on what type of brute force attack they use or a hacker is implementing, or how much computer power they are using, that kind of determine how fast they break the code. So if 4 pins doesn't work, so how about 8-digit pin code? So that's a lot harder to crack, right? Since it's more possible combination. Well, that kind of depends, because although it has about 100 million combinations, it will still lack complexity because you're still using 10-digit, like from 0 to 9. And if you have a persistent hacker that can go through 100 million combination, or if you have a lackluster security implementation on your system, then that's just a matter of time before the hacker can get to your system. So then what is the right way to set a complex pin or password? That would be combination of your digits 0 to 9, uppercase alphabets, lowercase alphabets, and if you add in symbols that will make it more complex. And make sure you aim about 8 or more character length of password. So let's say here, if we look at it, the counting password diagram here, or section. So this is the password length. So this one only has uppercase, lowercase, and digits. And an 8 password length character password will be about 218. How many much that is? That's a lot of combinations. So brute forcing kind of depends on how much complex and how many combination it needs to run through. So the more combination it needs to go through, the more it takes, the longer it takes. So, but even so, these are considered complex, but however, as a human being, we always want a password we can easily read and remember. So realistically, we throw in some words or names in our passwords, and we add in a little bit of symbols and numbers here and there. So, well, that's kind of a bad news, because we also have a method called, besides brute forcing, we also have a method called the dictionary attack. So where instead of sorting possible combinations, it kind of sort through words, so common words, names, phrases, some aliases for names, kind of common password patterns where you put in the letter, the uppercase in the first character, and then a word, and then you put in symbols here and there in the number. So that's a pattern that common password does, and the list goes on from there. And in addition to that, we have tools like Hydra here, where it combines dictionary attack and a brute forcing attack. So to crack password, so before you create a password, make sure to think twice before you make them, because you want to make sure that they're complex as possible. But as dangerous as it sounds, there is a lot of ways to prevent these attacks to happen. Some of the examples are, your multi-factor authentications. You make sure they're enabled to your system or your cell phones or laptops. Account device lockout. So if you type in 3 wrong password, it'll just lock out or ask you to change your password. And also password managers is one of them. So like, I believe a lot of web browser now has password managers like Chrome, and then when you make an account, you can generate a complex password, and then you can just save it through that manager, so you don't need to remember them. So make sure I would suggest that, to me at least, my practice is, in every account that I do or that I made, I make sure that passwords are different. I don't want to make one password for everything, because what if someone got your password, just one, and then they can get to all your accounts, like your bank accounts or emails. So make sure you put different passwords on all your accounts. Before we go to the task for today, something that I forgot is how to calculate the possible combinations for each pin codes or passwords. So if we're looking at here under counting pin codes, for you to know how many combinations your password has. So let's say here, this example is for digits from 0 to 9, which is a 10 character. So what you do is you count how many characters are in there, which is 10, and you multiply that to 4, and you will come up with 10,000, because 4 means 4 pins, possible combinations, so 10 to the power of 4, and you'll end up with 10,000. If we look at the complex passwords. So let's say here, a digit consists of 10 digits, 0 to 9, and if you add in an uppercase letter, the complexity will go up to another 26, so it's just 26th letter of uppercase, and the lowercase letter will add in another 26 characters in there. So if you add them all up, you'll be ending up 62 different choices of characters. So if you multiply that to 4, that would be about 14 million, and if you multiply that to 8, then you're coming down to this much. So that's something I forgot, but I just want to add it in. So yeah, we can go ahead and do our task. All right, for our task, we are going to have a VM today. I'm running my Kali Linux VM because I have the free version of the Tryhackme and I ran out of hours to run the attack box. So instead of using Tryhackme's attack box, I'm using my Kali Linux virtual machine, and I already use my OpenVPN to connect to their VPN, so I'm all good to go. So from here we go and visit the HTTP address to kind of see the pin code that we're dealing with. So we open another tab, paste. So we're here at our pin tab. So I have a split screen. I have my terminal here, and this is the websites. Okay, so it looks like we have 0 to 9 digits and A to F. And we can do the maximum of 3 characters on this keypad. Hit continue. That's the wrong password, so I can just do try again. All right, going back here. So our task for today is to generate a password list using Crunch. So what's gonna happen is, now that we know what characters we're dealing with, we're gonna use Crunch to basically make a list of possible combination out of these characters, 0 to 9 digits and uppercase letters A to F. Tryhackme does the example here already, so I'm just gonna explain it to you, what command involves in here. So Crunch is the name of the tool that we're using. So let's say here 3 is you're specifying the minimum length of the password that needs to be generated, and the maximum length of 3. And then from there you type in what characters that you need to be generated. So 0 to 9, A to F, and -O is you want to output the file to a text file named 3 digits as text. So if we can copy, I'm just gonna copy this, and I'll probably just go to my desktop so it will save there. So we just go copy, paste. There you go. And all right, so now it's generating the list. So about 16 megabytes. So it made 4,096 lines. So let's check it out. So ls is to list my file there. So let's cat. So cat is meaning concatenate. So we want to open the file and see what's in there. So it looks like it generated three codes and generated about 4,000 of them. So it didn't generate that much. So it's 3 digits probably, about 4,000. There you go. So now that we have this, I can just clear here. So using the password list that we have, now we can create, we can start using it and use it in Hydra. But before we start, I'll give you a little bit of what we're working here. Let's see. So it looks, so in here they kind of explain how we want to use Hydra in this website. So we go back to the website. So they said to inspect. So we inspect the source, or not inspect, but view page source. So now here, so now we have these HTML tags here. So what we're working here is we're trying to find how the forms tag. So the forms tag is a tag used in HTML to kind of send data over to the web server. So this pin running in the web, we kind of want to find out how, whenever we put a pin in here, where does it go, basically. So there's several methods used to specify, sending data through forms across the server, and one of them is post method. So if we look at here on the forms tag, it says form method is post. So what it does is whenever you input something there, it will go to this login.php kind of script to the server, and then it kind of authenticates you, then you'll be able to go in. So the action attribute within the HTML is kind of used to specify what the forms will be submitted to, which is login PHP. So when we enter something again, it will go submit to login.php. So if we go back to Tryhackme again, right? So whatever they explained here, I kind of explained it briefly. So we have here Hydra, which is our tool that we're using. L means it's the login username, which in this case we don't have. So we're putting a placeholder of 2 commas here, just to say that it's blank. And we're trying to use this password list that we did. So -p means password. What word list do we want to use? And in this case, we're using the 3 digits, the text. And the -fs means it will stop the Hydra when it found the right pin or right password. And -v means verbose. So when we hit enter here in a second, it will list a lot of it will kind of list what it's doing. So if we run into trouble, it kind of used for debugging. Like let's say I miss something here, instead of not being able to know what the details are without this verbose, now that we have it, it will kind of show where the failure went, or what's the failure is about. And then this is our IP address of our target, and here this is inside the Hydra http-post.form. So basically we're telling Hydra that we're using a post method through form. And this one is separated within these semicolon. So login.php is where we're submitting the forms, and then pin equals pass. So this means this is another placeholder for the -p 3 digits, the text. So anything that this runs, whatever whatever the codes that is in here will go here, basically, this placeholder for -p. And then anything access denied will be, we won't show, basically. So it kind of leads to that. And -s is the port, which is 8000. So we can hit enter on this. So now it's trying to run. So like what I said verbose earlier. So it's saying error.php. It means that's not the right, got redirected to the access denied. So it means that's not the correct pin. All right, so looks like the command that we did through Hydra went through. So it says here that we got the password 6F5 and it finished successfully. So we can actually use this and try to enter this pin through this keypad. So 6F5. All right, so it looks like we got in, and let's see here. We can just unlock the door. Okay, so now we're presented with the flag. So what it is these challenges kind of it's like a capture the flag kind of setup. So they to all of the challenges will present this flag every time we successfully finish them. So now we can just submit it here. And that completes our task for today. Let's see. So yeah, so you see how all these, so today we kind of learned about, so going here to learning objectives. So we learn about password complexity, how it is important to make one on each of your accounts, and how it affects brute force. I mean, I believe when I did so for this one through Hydra, it kind of depends on the system or the computing power you have. So I paused it, the video a little bit, but the Hydra took about like 5 minutes to run, through those word list and to find the right password. So depending on how complex is the password, that kind of affects the brute forcing method that we use. And we, this tool like Crunch and Hydra, they're a very powerful tool. I mean, I believe a lot of people use them, but there's also other tools that kind of has more ability to do. Like I believe Crunch can only do password generation. Hydra is a very powerful tool, but we only kind of show the basics of it. But it's up to you if you want to know more about it. Hydra, you can go to their documentation again. But yeah, this is a very good day 3. I like it how they did a lot of red teaming, and I believe maybe the next one will probably about blue team, but we'll find out. But yeah, thanks for watching for today, and I'll see you guys on the next video.